So we continue with this example for solving for linear equations. Again, we're going to determine a solution. A solution is when we have an equation and we're going to find the value of the variable, and in this case it's x. Find the value of the variable so that when we use it, it makes this equation a true statement. So we'll go ahead and we'll rewrite this equation here. 4x over 9 plus 7/3. That is equal to 9. Now let me just point out a couple of things here. 4x over 9, if we have it like this, 4x over 9, that is the same as 4/9 x. It's just two different ways of writing the same thing. Don't forget 4/9 x, that means 4/9 times x, and x can be written as x over 1. And when we multiply straight across. So if I was to multiply straight across numerator to numerator, I have 4x. And denominator to denominator, I have 9. So whether it's written as 4x over 9 as we have here, or whether it's written as 4/9 x, it means the same thing. Also, we have these denominators. And if there's one thing that students get hooked up on is denominators, but they're all part of the solving process. So we're going to get rid of these denominators first and foremost. And we do that by introducing a common denominator, and preferably a lowest common denominator. So since our denominators here are 9 and 3, the smallest common denominator between these two would be 9. So I'm going to introduce a multiple or a factor of 9. And we can do that a couple of ways. We could either do it to either side. I'll go ahead and introduce 9 to this side. What you do to one side, got to do to the other. We could either do it that way, or rather than doing it to either side individually, we could just do it in one big group. Just do the whole thing at once like this, and just know that this factor gets multiplied to each term of the entire equation. They both mean the same thing. This may just be a little more economical way of doing it. So now what we have is we have 4x over 9 times 9. Here the 9s are going to cancel. That's the whole idea. So I'm left with 4x. Distribute the 9 again. 9 times 7/3. 9 times 7 is 63. And 63 divided by 3 or 63/3. That's 21. And then, of course, 9 times 9. And over here, we distribute 9 times 9. That's 81. So the first thing we did is we wound up dealing with the denominators. And now we have something that looks like it's all straight in line here. It seems to be simpler to approach. Now, again, using the addition property, I'm going to subtract out 21 from either side because we're looking to get this term by itself because we want to isolate that variable there. I'll subtract out 21 on this side. Those will cancel. I'm left with 4x. That's equal to 60. 81 minus 21 is 60. We could do the same thing that we did up here. We can go ahead and we can group the whole thing at once and then multiply by its reciprocal, which would be 1/4. The reciprocal of 4 would be 1/4. Or we could do it to each side individually. Or what we can simply do is just divide either side by 4. It all means the same thing. These factors will cancel, which is the whole idea. X is equal to 60/4, and 60/4 is 15. So if we did this correct, then the solution to this linear equation is 15. So what we'll do is we'll check it. We'll go ahead, and if x is 15, if we use it, then it's going to make this a true statement. So we'll do that. We'll do 4x, and what is x? 15. Over 9 plus 7/3 Does that equal to 9? Now, you should resist using your calculator as much as possible unless it's absolutely needed. So what we're going to do here is, here's 15. 15, what does that equal to? Well, that equals to 5 times 3. So 4 times 15 is the same as 4 times 5 times 3. So I'm going to rewrite this as 4 times 5 times 3. It's the same thing, right? And 9 can be written as 3 times 3. So what that does is it reveals the factors of these values here. Plus 7/3, that's equal to 9. That way I could just go ahead and cancel out a couple of common factors here, 3 and 3. So now 4 times 5, that's 20 over 3, 20/3. Plus 7/3, does that equal to 9? 20/3 plus 7/3, that's 27/3. And 27/3 does equal to 9. So it looks as though 15 up here is our solution. So it looks like it works. And there we go.